Hello. Today we will be working with inequalities. We're going to review properties of inequalities. We'll learn to use interval notation, and we're going to look at solving several different types of inequalities. Let's begin by looking at our objectives for today. First, we want to review our properties of inequality. Solve and graph linear inequalities. Learn to use interval notation. Solve three-part inequalities. Solve quadratic inequalities. And solve rational inequalities. Let's begin by reviewing our properties of inequalities. First, for real numbers a, b, and c, a is less than b and a plus c is less than b plus c are equivalent. Second, if c is greater than 0, that is, c is positive, then a is less than b and ac is less than bc are equivalent. Lastly, if c is less than 0, then a is less than b and ac is greater than bc are equivalent. Now remember, we can replace our less than symbol with any of the variations of our inequality symbols, and our results are still valid. Let's look at an example of a linear inequality. A linear inequality in one variable is an inequality that can be written in the form ax plus b is greater than 0, where a does not equal 0. Let's look at this example. We have the inequality negative 3p minus 2 is less than or equal to 1. Now the first thing we want to do is to add 2 to both sides of this inequality. This results in an equivalent inequality, negative 3p is less than or equal to 3. Now we'd like to multiply both sides of this inequality by negative 1/3. Now remember, we must change the direction of our inequality sign. It now is a greater than or equal to sign. Simplifying leads to p is greater than or equal to negative 1. The solution, remember, is the set p such that p is greater than or equal to negative 1. We can look at the graph of this solution on our number line, mark the point negative 1, and since we want to include negative 1, we'll put a bracket there, and we'll shade in the number line to the right. Now here's a problem for you to try. Remember to write your solution as a set of numbers and to graph your solution on the number line. Let's look at this solution. First, we want to add 3 to both sides of the inequality. This gives us negative 5x is less than 10. Now we can multiply both sides of the inequality by negative 1/5. Did you remember to change the direction of the inequality sign? Now let's look at the graph of this solution. We have our number line with the point negative 2 marked. We have a parenthesis there since we do not want to include the value negative 2, and we've shaded it to the right. In set notation, this is the set of all x such that x is greater than negative 2. Now there's another way we can write the solution to this set of numbers. Did you notice that we have an interval here? We have a notation called interval notation, and it starts with our number negative 2. Our interval starts on the left and extends indefinitely, and we indicate this by using the infinity symbol. This is an example of interval notation. Again, it consists of 2 numbers or symbols, the smaller number or symbol on the left and the larger one on the right. Now in this case, we have parentheses around both negative 2 and infinity. We put parentheses around negative 2 since we do not want to include that value, And we put a parenthesis around infinity since we never reach that value. We call this an open interval. Here's another example of an open interval. The set of all x such that x is between 2 and 5. Look at the graph on the number line. We've marked the numbers 2 and 5. We've put parentheses around them and shaded the values between them. In interval notation, our 2 is on the left, our 5 is on the right, and again we have parentheses around both 2 and 5 since x cannot include those values. This is again an open interval. Let's take a look at this inequality. Here we have the set of all x such that x is greater than or equal to 1 and less than or equal to 4. On the number line, we've marked the numbers 1 and 4, and this time we've put square brackets around the 1 and the 4. This indicates that we want to include those values, and we've shaded in the values between 1 and 4. Now our interval notation will still have used two numbers or symbols, the smaller numbers on the left, the larger numbers on the right. But again, notice this time we put brackets there since x can equal 1 or x can equal 4. We call this a closed interval. Here's another example of a closed interval. We have the set of all x such that x is greater than or equal to -2 but less than or equal to 0. Our two numbers again are -2 and 0 with brackets around both, and we've shaded the numbers between. Our interval notation begins at -2 and extends to 0. Again, we put brackets around both, and we call this a closed interval. Now sometimes we'll have inequality statements that contain both less than signs and less than or equal to signs. Here's an example. We have the set of all x such that x is greater than -2 but less than or equal to 5. We again mark our two numbers on our number line, -2 and 5. But this time we put a parenthesis around -2 since x cannot equal -2, but a bracket around 5. Our interval notation will start at -2 and extend to 5. Notice how we have a parenthesis on one side and a bracket on the other. In this case, we call this a half-open interval. Here's another example of a half-open interval. The set of all x such that x is greater than or equal to -2. We mark our number line with -2, put a bracket there since x may equal -2, and shade in all the values to the right. So our interval notation will have a value at -2 and extend to infinity. Again, notice we have a bracket at -2, a parenthesis at infinity, and we call this again a half-open interval. Now, from now on, when we solve our inequalities, we will write all of our solutions using interval notation. Now, another kind of inequality we can look at is a three-part inequality. For example, here we have -3 is less than or equal to 2x minus 1 is less than 9. We might say that 2x minus 1 is between -3 and 9. To solve this, we want to isolate x in the middle. So the first step would be to add 1 to each part of this inequality. This results in -2 is less than or equal to 2x is less than 10. Now we might want to multiply each part of the inequality by 1/2. This will give us -1 is less than or equal to x